In Creo Parametric, you can create a statistical design study in order to perform a complex tolerance analysis. In the previous videos, we used MathCAD in order to compute the standard deviations of our critical dimensions. We also created a datum analysis feature in order to create the measurement that we want to control. And we also did a multi-objective design study in order to create a response surface. Now, I do want to point out there's one mistake I made in the last video. Let me go to the multi-objective design study. I'm going to retrieve another design study. Now, in the previous video, I should have changed the limits of the design variables to their actual tolerances. So I did that. I reran the multi-objective design study. Now let's go ahead and create our statistical design study. So I will click on the command, and here we have the dialog box. You can rename the design study if you want. Then we have two different choices, single or mods. And I'm going to use the single option. The single option is going to perform the study at a single point, but if you use the mods option, it's actually going to create the study distributed over a design space. Essentially, it's going to do a multi-objective design study for the statistical design study. We don't need to do that. All right, let's go to the setup command. Here's where we can choose our mods response surface, and I will select the correct one. I'll click the OK button, and here we have our two different dimensions and our design goal. I'm going to select the length dimension and go to Properties, and here we can see the minimum and the maximum limits. It's that plus or minus 0.1 from our dimension. I had to rerun the multi-objective design study because I'd accidentally used the default plus or minus 10%. Then here we have the distribution that we want to use. And we have a few different choices. We could use normal, that's the default. You also have uniform, log normal, exponential, and Weibull. I'm going to jump over to MathCAD for a second. So if you're interested in the functions for the different statistical distributions, here they are. You can see what normal is, and uniform, exponential, log normal, and the Weibull. Also here in MathCAD, I can take a look at what the standard deviations are. So for the length dimension, it is 0.033, and for the angle, it is 0.33. I need that information. Let's go back to Creo Parametric. Here we can see our mean value, and then here is the standard deviation. And again, for the length dimension, it is 0.0333. Let me hit the enter key. You can see how it updates the distribution in our window. Let's click the OK button, and let's repeat that for the angle dimension. Let's go to the properties, and we've got our minimum and maximum, our distribution, our mean value, and the standard deviation in this case is 0.333, and then it updates the shape of the distribution. Let's click the OK button. And so now that we have our design variable set up, let's hit the compute button. And we've got our minimum and maximum and our mean value. Let's select our design goal. Now we can go to properties, and this is where we get the information about our results. So again, for our critical measurement, we can see that the mean value of the height is 2.217, and the minimum value is 2.14, and the maximum value is 2.9. And we can see the standard deviation for the height measurement. Now, where you get the value out of the statistical design study is by specifying your limits. So the lower limit in this case, let's say it is 2.17. I'll hit the enter key, and you can see how much falls below that lower limit. In this case, we would only be getting 2.1 sigma below our mean value. Now let's put in our upper limit. Let's say that the maximum that this can go to is 2.26. Hit the enter key. And so now we see that we're only getting 1.93 sigma above our mean value. That is falling within our requirements for the height measurement. We also have our DPMU. This is the number of defects per million units. And so we can say, hey, is this something that we can live with or not? Probably not, because usually you want to get 6 sigma plus or minus 3 sigma on each side. So you would probably have to go back and change the tolerances of the length and angle dimensions in order to get that. And what's nice about this, you can see, hey, let's say that our minimum requirement was 2.18. Hit the enter key and we can see how that affects our defects per million units and the sigma value. Let's try again. Let's change this to 2.25. And so we can see that, yes, as we decrease our limit, our number of defects goes up, and so our number of sigmas goes down. And that way you get a sense of what you need to make changes to in your definition of your part in order to get the yield that you want. And so that's the power of the statistical design study. So this is good. Let's click the OK button out of there. And then from the file menu, I'm going to choose to save this, and we can always retrieve it and take a look at it later on. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.